Hello students. Previously we learned about the combustion, oxidation and addition reactions of hydrocarbon compounds. We are now left with one more type, the substitution reaction of carbon compounds. Substitution means the removal and replacement of something. On the same lines, an atom or more from a compound, if it is removed and a new atom or molecule is added in its place, such a reaction is called substitution reaction. It is needless to say that in case of hydrocarbons, hydrogen atoms are substituted by newer heteroatoms or functional groups. Thus, one atom or a group of atoms displaces hydrogen atoms to form new compound in substitution reaction. In fact, students, not only hydrogen but alkyl groups can also be substituted in saturated hydrocarbons to form new compounds. Now the question is, does the substitution reaction occur in all hydrocarbon compounds? No, the substitution reaction occurs only in saturated hydrocarbon compounds. Do you remember which hydrocarbon compounds are saturated? Yes, you are absolutely right. Alkene compounds are saturated hydrocarbons. And as we know, in such compounds, all the valencies of carbon atoms are satisfied by single covalent bonds only. While the unsaturated hydrocarbon compounds such as alkenes and alkynes have double and triple bonds respectively. Thus, substitution reaction does not occur in them because here double and triple bonds can break and new atoms or functional groups can be added at these freed valencies of carbon. Thus, they give addition reactions and not substitution. Note that in addition reaction, we have not removed any hydrogen atom. In fact, we have added newer ones. While in substitution, we have to first remove the hydrogen atoms and then they will be replaced by other atoms. Thus, we clearly see that saturated hydrocarbons give displacement reactions, while unsaturated hydrocarbons give addition reaction. Now, we have already studied that single covalent bonds are relatively strong, isn't it? Yes, and thus compounds having them are relatively stable. The saturated hydrocarbons, that is alkanes, are less reactive with most of the reagents as compared to alkenes and alkynes. So does this mean that they don't take part in chemical reactions at all? No, that's not true. They do take part in the reactions, but only when they are forced to do so. And how can we do that? It's simple. By changing reaction conditions like keeping high temperatures and pressures, or by using catalysts. Under such conditions, alkanes lose one or more hydrogen atoms and are replaced by other atoms or group of atoms. Let us understand with the example of methane, the simplest hydrocarbon. When methane reacts with chlorine under normal conditions, the reaction is very slow, almost non-existent. But when the same reaction takes place in the presence of sunlight, it is really quick and forms methyl chloride and the byproduct hydrogen chloride. Look at the structure of methane. We know that alkanes can't make new bonds as all the valencies of carbon atoms are satisfied by single covalent bonds, just like here. So one way for it to participate in the reaction and form new compounds is to remove one or more hydrogens from the chain and replace them with newer atoms. When methane is reacted with chlorine in the presence of sunlight, one of its hydrogen is removed like this. Now you can see here that one valency of carbon is set free and it is ready to bond with the another atom. So this position is occupied by chlorine atom. As a result, methyl chloride or chloromethane is formed. But what about this displaced hydrogen atom? Yes, it reacts with this remaining chlorine atom to form hydrogen chloride. Since the hydrogen atom was replaced by the chlorine atom, this becomes substitution reaction. Now can we displace other hydrogen atoms from this chloromethane? Or let me put it this way. Can this substitution reaction happen again once it has happened? The answer is yes. It can happen. What happens is one more hydrogen is displaced from chloromethane when it reacts with chlorine under same conditions. And it is replaced by one more chlorine atom. And just like the previous reaction, the removed hydrogen forms HCl, that is hydrogen chloride. The product obtained here will be dichloromethane or methyl dichloride. Can you now predict what will happen in the next round of substitution reaction? Yes, one more hydrogen from dichloromethane from here will be removed in the presence of sunlight and it will be replaced with a chlorine atom and we get trichloromethane or hydrogen trichloride. Do you know this trichloromethane is nothing but chloroform? The trichloromethane now produced here reacts with the chlorine atom again in the presence of sunlight and forms tetrachloromethane by replacing one last hydrogen. Can this reaction happen any further now? No, it's not possible. It is because we can see here that in methane we have replaced all the hydrogen atoms that were present. Carbon now cannot form new bonds because it's a tetravalent atom satisfied by chlorine atoms. And so reaction stops here. Thus in all these reactions, chlorine molecules displace one hydrogen atom after the another from methane, producing different products with different but specific properties. And at the end, we get tetrachloromethane. Now let me ask you, how many times this substitution reaction can continue for any hydrocarbon compound? The simple answer is that it can be done for as many replaceable hydrogens present in the compound. Let's say ethane has 6 hydrogen atoms covalently bonded to these 2 carbon atoms. 3 each, isn't it? Yes. So here, all these 6 atoms can be replaced by chlorine atoms to form hexachloroethane. This means substitution reactions can continue for 6 times, replacing 6 hydrogen atoms one after the other with chlorine atoms. Again, this is true for any halogen atom like fluorine, bromine or iodine. But it may or may not be true for functional groups like aldehydes and ketones. To generalize, we can say that variety of products can be produced by substitution reaction. This is because as we go on taking higher and higher alkanes, the length of the chain increases, and so hydrogen can be displaced from different locations in different hydrocarbon chains, and each time a new product with new properties will be formed. In this way, various products can be obtained by substitution reaction, which are used in industries or on a commercial purposes. So students, so far we have learnt about various chemical reactions of carbon compounds such as combustion, oxidation, addition and substitution. In the next video, we will learn about some important carbon compounds used in our everyday life.